something in the real world, apply what we're learning here, and at the same time review some concepts. So suppose I have an oven of some sort. We have one downstairs in the materials lab. So for those of you who took the materials class, you may have noticed it off to the side. We didn't use it in the spring semester, but we do have an oven down there. And it's an electric oven. So the way it heats itself is it has a resistor in it. And we pass current through that resistor. And as you pass current through the resistor, that resistor gets hot. So in fact, all the power absorbed by a resistor is released as heat. Do I need anything special about this resistor? Like in other words, do some resistors release, are some resistors more efficient at releasing the energy as heat than others?
Is it based on their specific heat capacity?
Their specific heat capacity would dictate how much time it would take to get hot. So whether it takes 3 seconds or 8 seconds to first warm up would be affected by the specific heat capacity. Once it got hot, the specific heat capacity of the resistor wouldn't affect how efficiently it would release the heat. But good thought. So Isaac's saying, could the specific heat value of that resistor make a difference? Roger.
Small resistor size?
So the small meaning a small
like
value?
Ohms, yeah. That's it.
Well, that's a good question. We're actually, to some extent, going to address Roger's point down here. I think Roger's not so much coming at the efficiency, but thinking, what value should I pick here to absorb the most amount of power? So the power absorbed by this resistor would be current times voltage. So if I have a small resistor, that's going to make the current go up, if I had some fixed voltage over here. So a small resistor will make more current. And if the voltage were fixed, more current, same voltage, more power, as Roger said. It wouldn't affect the efficiency, how much heat it would be producing, but it would produce more because there would be more power going to it. In practice, that voltage, whatever that voltage source would be connected to it, wouldn't be a perfect voltage source. It would have some resistance to it. And that internal resistance will help us determine exactly what size resistor I should use to get the most power. So that's actually a good point, because we're going to address exactly that question later today. Well, that first question I asked of, are some resistors better than others in terms of efficiency for producing heat? The answer is no. So when a resistor produces heat, any resistor, all the ones we have in lab, all the power they absorb is released as heat. Now, maybe some of them release a little bit as light, but whether or not you consider light to be a form of heat is up for some matter of opinion. Some of those infrared lamps for heating things are sending a form of light to heat something up. So if someone said, what's the efficiency of that resistor heater, you could say that's kind of silly. Okay, so I've got my oven, got the resistor in there, trying to heat it up. I also have some kind of temperature gauge inside the oven. So this is my, I'll put a T here, for temperature sensor. A common type of temperature sensor, you don't need to memorize this term. A common type of temperature sensor is called a thermocouple. It's a little device that produces a different voltage depending on how hot it is compared to the inside of the oven compared to the outside of the oven. Okay, so this little device is going to produce a voltage difference depending on how much hotter the inside of the oven is compared to the outside of the oven. This is actually a very simple device. You basically just take two different metals and butt them against each other, and that will produce, just that alone, will produce, for complicated reasons, a teeny little voltage that's different depending on how hot the inside of the oven is compared to the outside of the oven. So that really is that costs not dollars, but cents to make something like that. The downside of this little device is it produces, the voltage difference is not like 8 volts. It's 8 millivolts. How many volts is 8 millivolts if you convert it?
0.00?
Yeah, 0.008. So this is producing a very small amount of voltage. So what I'd like to design is some system that has an adjustable knob that lets me control the temperature inside the oven. Okay? So I've got a resistor that's producing heat to the oven, and I've got a temperature gauge that reads a bigger number when the oven gets hotter and a smaller number when the oven is cooler. Any ideas so far? So I've got some wires coming out of this thing. I've given you a hint that maybe we're going to use an op amp somewhere. Isaac?
Connect one end of the resistor to an op amp and then ground the other side of the resistor.
Connected to the output of the op amp or the input of the op amp?
Input.
So connect that to the input.
Yeah.
Okay. And then what should I do with the other input?
Ground it.
And then the output?
Go to the other side of the resistor. I'm not sure.
Okay, good thought though. What Isaac just did is great. Let me explain why. We have a design problem. We don't know how to begin to approach it. Okay. If you choose between one of two strategies, one is I'm stuck, I don't know what to do. And if you ever allow yourself to get frozen there, that's the worst thing that can happen. Isaac, rather than getting frozen, he threw something out there. Said, let's look at this and see what it does. By throwing an idea up on the board, we have a chance of looking at it and saying what might be wrong with it, what's it missing, what big pieces is it missing, and we can try to improve on it. If you have no idea at all, it's very hard to improve or do anything with the design. So I see one flaw with Isaac's design. What doesn't Isaac's design take into account at all when regulating the temperature of the oven? It doesn't take into account what temperature is currently inside the oven. So we'd have no way of, this circuit right now would have no way of detecting the temperature and then doing anything different with that. I guess what we're kind of hoping this circuit will do is somehow compare the temperature of the oven to some fixed point. And if it decides the temperature is too low, put current through the resistor. Heat up the oven more. If the temperature is too high, stop doing that. Stop sending current through the resistor and stop heating up the oven. So I'm looking for the circuit to have some kind of trigger point where if the temperature is too big, then shut down the resistor. If the temperature is too low, turn on the resistor. Jerva.
So then we need a power source, right? Going into the thermocouple?
The thermocouple actually...
I mean into the op amp.
All right, so suppose I've got this connected to plus 10 volts compared to reference, and let's just make it ground. Okay. So I've got the op amp now powered up. Sometimes we won't bother to draw the powers in the op amp, we'll just assume it's powered up. But it's good to, if we're actually designing anything we're actually going to build in a lab, we should know how we're going to connect this op amp. So that's good. Fun.
So the thermocouple creates electricity, so we need to figure out what it creates so we can find the
Let's say the
point.
range of this thermocouple is between
Find
0
where
and 10 millivolts or something like that.
Alright.
So if it's right at room temperature, it's going to read 0. And if it'll go more than 10 too if we got a hot oven.
Yeah.
So, but within the range of temperatures we're interested in, let's say it ranges between 0 and 10 millivolts
Okay.
in terms of what it produces. Roger.
You need to set it up so there's kind of like some kind of feedback, right?
Okay, yep,
Like a
Yep.
negative feedback?
yep. Good. So we need some kind of, there'll be some feedback in this system overall. Matt?
I think what you need to add the switch providing power from the, how you control the temperature, like the knob.
Like a new component?
On the positive side of the op amp,
Like here?
and on the negative, have the one end of the thermocouple.
Okay, so let's try putting one end of the thermocouple on the negative side. How about that side to reference?
Yeah.
We've got some voltage here that's ranging between 0 and 10 depending on how hot it is. your suggestion there?
But we need to have some kind of, feed from the switch, from the
Okay.
knob that's providing between,
So instead of going to the resistor there, maybe here we'll do something with the knob.
Like a rheostat kind of thing?
And for the knob,
got an output voltage that is,
Within the thermocoupling range?
yeah,
yeah.
so maybe our knob should be a voltage divider. We haven't done a whole lot of different kinds of knobs in lab. Not all of you have gotten to the knob lab where I ask you to make a circuit. I think maybe 2/3 of you have gotten to that.